So we continue with our 2014 November paper. Okay, so this question it's on variation, so we're going to cover this question on variation, and then the next question that we're going to cover, it will be on similarity. Okay, ratios of volume. So this one will be critical as well. Okay, so the first question, question 11, it says the time t hours varies inversely as the speed s kilometers per hour. Okay, so you're asked to express t in terms of s and constant d. So this is variation. You're told that this is inverse variation. Okay, so part A, express t in terms of s and d. So you first have to state the relationship using the constant of proportionality. So the constant of proportionality, it's this sign here. Okay, so you're told that t varies inversely. When they say inversely, you put your constant of proportionality, but then you have to say 1 over whatever variable that they'll be talking about. So for our case, it's s. Okay, so it's t equal t is proportional to 1 over s, like this. So when you remove this constant of proportionality and replace it with an equal sign, you actually have to introduce a constant here. Now normally we introduce constant k for just general equations, but then here you're actually told that the constant is d. So it should be d over s. It's d over s in the sense that d here would be k, so k would be multiplying whatever you'd be having here. So it'd be k multiplied by 1 over s. So you just get k over s. For our case, k was equal to d. Okay, so this one would be the relationship. You don't leave it like t directly proportional to 1 over s or t proportional to the inverse of s. You actually have to leave it here with the equal sign. So the B part asks us to calculate the constant d when t is equal to 12 minutes and s is equal to 15 kilometers per hour. So whenever you're dealing with either multiplication or division of quantities for which you know the units, so for example this one is in minutes, this one is in kilometers per hour, you have to match the units. Okay, so the way that you do it is they told you to calculate constant d. So you have to change the subject first. So I'm going to start writing from here. Okay, so here you have t equal to d over s, like this. So you want constant d, you have to get rid of s. How do you get rid of s? You just multiply both sides by s. The reasoning here is that s it's divided here. So in order to get rid of something that's divided, you actually have to multiply by that factor. So you just get, I'm going to rearrange here in one step. So you just get d equal to ts, like this. Okay, so you're told that t is equal to 12 minutes, but then you should change this one to hours so that it matches with the units here. Okay, so this one will be 12 over 60 hours, like this. Okay, and s is equal to 15 kilometers per hour, like this. So when you substitute, what do you get? You get d equal to then t, which is 12 over 60 hours, like this, then multiply by s, which is 15. You can say kilometers per hour simply means kilometers over hour, like this. Okay, so that's why these two, they actually do cancel. Then you can also simplify on our fraction. So this one the highest common factor between 12 and 60, it's actually 12. So you say 12 into 12, then you say 1, you get 1. 12 into 60, then you get 5 here. Then 5 into 5, then you get 1. Into 15, you get 3 here. Okay, so at the end of the day, you actually get 3 kilometers here. This one will be your final answer. Okay, so we're going to move over to our second question for this video. So the second question says you have two similar drums. They have diameters in this ratio. So the ratio of diameters it's called the scale. So it's the length ratio. So when you're asked to calculate the ratio of their volumes, it should reflect on the ratio of the diameters of or the length ratio. So part A, you asked the volume, the ratio of the volume. So you say volume ratio. So volume ratio equal to length ratio cubed. Okay, so one way to remember this is when you're dealing with volume, usually we use cubic units, so cubic centimeters and cubic meters. Okay, so this cube here, you can remember it from that. And then also area ratio would be square. Okay, so you should take the length ratio and then you square it. Already you know the length ratio here. The length ratio it's 3:5. So 3:5 simply means 3/5 here. Okay, this is another way of presenting ratios. You can present them as either this format where you say 3, then you put a semicolon, then you put a colon, then you put 5. Or you can actually put it as a fraction in this form here. Okay, so this one is cubed. If you have a fraction and then you have to cube it, that means you can distribute the cube. So the cube has to affect the numerator, so you'd be getting 3 to the power 3. Then it also affects the denominator, so divide by 5 to the power 3. So 3 to the power 3, it's equal to 27. Okay, so and then 5 to the power 3, it's equal to 125. So you actually get 27 over 125. This one would be the volume ratio. If you asked to find the area ratio, again you say length ratio squared. Okay, that's how you do it. So you're dealing with this ratio here. Let me quickly wipe out this part because we don't need it, but then the volume ratio, we actually do need it. Okay, so part B, so part B is you're told, given that the volume of the bigger drum is 100 liters, calculate the volume of the smaller drum. So you're given the volume ratio is 27:125. So obviously the 125 is corresponding to the bigger drum. Okay, so you can actually use a simple proportion here and say 27:125 here, and then you have to know that 125 corresponds to the volume of the bigger drum. Okay, so here the 100 liters, you're told that the 100 liters is for the bigger drum, so you can actually write 100 liters here. Okay, 100 liters should correspond to what? To less. If it's less, you're supposed to say smaller number at the top. Okay, so you actually get 100 liters here over 125 multiplied by 27. Okay, like this. So you can use 25 here and say 25 into 125. What do you get? You just get 5. Then 25 into 100. What do you get? You get 4. Okay, so at the end of the day, you get 4 by 27. So 4 by 27 divided by 5 here. So you should be able to get 4 by 27 by 2. You get 54. Then 54 by 2 again. Then you get 108. 108 divided by 5 is the same as saying 216 divided by 10. So you just get 21.6. Okay, so just verify that you get 21.6 here. So it should be 21.6. This one would have units, so the units would be liters here. Yeah, so that's just about it for this question. If you haven't subscribed yet, then make sure you do, and also like and share the videos because it helps others discover our channel. So thanks so much for watching. I'll catch you in the next video. Yuba, out.